Good day, welcome back to our channel. I'm Maile Matsiba. Today we're going to be continuing with section 2 of the 2017 study guide. We're going to be looking at example 2.7.1. It says a solution in water contains 0.24 kilograms Na2SO4 per kilogram water. Now the question is, express this concentration as A, kilograms Na2SO4 per kilogram solution, B, mass fraction, C, mole, not fraction, rather mole percentage. Let me just fix it here. Mole percentage. So answering such a question, it's always important. Okay, another thing I want to highlight is that we have been given that the mole mass of Na2SO4 is actually 142 kilograms per kilomole, or 142 if you may put it that way. So answering such a question, the first thing, a very important thing that we need to do is to choose a basis. And the basis we're going to be using is the basis that has been used in the study guide of 1 kilogram water. Now, this is the basis that we're going to be using. So, answering the question, starting with A, that we calculate them, we get to find the kilograms Na2SO4 per kilogram solution. The first thing we need to find is the masses of both Na2SO4 and water in the solution. And we know that based on the basis of 1 kilogram water, then the mass of Na2SO4 equals to 0.2 kilograms, and the mass of H2O equals to 1 kilogram. Now that means the mass of the total solution then becomes 0.24 kilograms plus 1 kilograms, which becomes 1.24 kilograms. Now if we're going to express a kilogram Na2SO4 per kilogram solution, then it's going to be, let me just write here that, let me just say kilogram, let me use the longer root, which I really love. Kilograms Na2SO4 per kilogram solution is equals to 0.24 kilogram Na2SO4 all over 1.24 kilogram of the solution. Now that gives us 0.1935 kilogram Na2SO4 per kilogram water. So that is our answer for A. Now going to B, they say we should calculate the mass fraction. Now, since they didn't really specify mass fraction of what, then we're going to be calculating the mass fraction of both the water and the Na2SO4. So let's start with Na2SO4. Mass fraction Na2SO4, since we already have the masses, it will be 0.24 kilograms all over 1.24 kilograms. That becomes 0.1935. The kilograms fall off, and now that is our mass fraction. Now the mass fraction of water equals to 1 kilogram all over 1.24 kilogram, which then gives us 0.8065. Now the kilograms follows, and those are our mass fractions. Now going to C, our C, or our third question says they want the mole percentage. C says they want the mole percentage. Now with the mole percentage, what we need to, now that we're going to be working with moles, then we need to calculate the moles of both the Na2SO4 and also the moles of the H2O. So let's start with Na2SO4. Na2SO4 moles Na2SO4 equals to the mass of Na2SO4 all over the mole mass of Na2SO4. Excuse my handwriting. So it becomes the mass of Na2SO4 is 0.24 kilograms, and now the mole mass of Na2SO4 already we have been given that it's 142 kilograms per kilomole. Now that becomes 0.00169 kilomole. Now these are the moles of Na2SO4. Now we need the moles of water. Mole H2O is equals to the mass of H2O all over the mole mass of H2O. The mass of H2O, we know that it's 1 kilogram, and the mole mass of H2O, we know it as 18 kilograms per kilomole. You can get that from the periodic table, or you can even just know it off by head. Now the answer becomes 0.05556 kilomole. And another thing, I try to use more digits just so that I can enhance my accuracy. Now the total kilomoles of the solution becomes 0.001690 kilomole plus 0.05556 kilomole. That equals to 0.057246 kilomole. This is our total kilomole, but our question says they want the mole percentage. But now that we have the total kilomole of the solution, and we also have the mole of each individual, like for both Na2SO4 and also H2O, then we can easily calculate the mole percentage. So now it becomes just some simple arithmetic. Mole percentage Na2SO4 becomes is equals to mole Na2SO4 all over total mole multiplied by 100%. So that becomes mole Na2SO4 is here. Yeah, it's 0.001690 kilomole all over the total kilomole becomes 0.05724. Yeah, 0.57246 kilomole multiplied by 100%. Now the kilomoles will have to fall off, and then you get 2.95% Na2SO4. So that is the percentage. Now the mole percent of water becomes, using the same equation, we'll just say 0.055556 kilomole all over 0.057246 kilomole multiplied by 100%. Now this equals to 97.05% H2O. Now, just as an additional, just for interest's sake, we can all actually moving from here to here, we could actually use simple arithmetic to know that 100%, we can use the 100% principle and say, well, should I say an alternative? Or we could say mole, let me just say, write it underneath and say mole water equals to 100% minus mole Na2SO4. So yeah, so which would be 100% minus 2.95%, and that would still give us 97.05%. Well, it's important to understand that this moves us from here into here. So we could do it directly from the information or the data that we have, or we could use this knowing very well that if we have this then and there are only two in the solution, then we can easily get to this. So thank you guys for your time, and thank you also for continue supporting the channel. I hope to see you again in the next video.